Okay, let's talk systems of linear inequalities. We've talked systems of equations, and we've solved those systems of equations. We're going to kind of navigate towards inequalities and how these inequalities apply to systems. So we want to be able to graph and solve systems of inequalities. All right, so what are we really doing? Let's remember a system of equations where we had two equations, two unknowns. That was where is the point where the lines would intersect. So one point x comma y that worked on both equations. We could also have no solutions if they were parallel lines, or infinite solutions on a graph if they were the same line. Okay, so it was a system where we had two equations. Now we're going to look at two inequalities. Okay. The big difference here is noticing the symbols there. So a solution to a system of inequalities is going to be the region of points where the shading intersects. So all the points that work in both inequalities. So if I graph each of these lines, okay, here's our first line. It's a solid line because it's got the less than or equal to. And our second line is strictly greater than, so that's why it is dotted on the graph. And here's my region of points that work in both. So any ordered pair in that shaded region will work in both inequalities. We're going to see how to find that region. We've got two examples. Here's my first example. I'm going to do the first example in one color, and then I'll change. And you should do the same thing. All right, for this first line, okay, in order to graph, I want y equals, or y by itself, okay? So if I subtract x from both sides, this first line becomes y is greater than negative x minus 3. On the graph, my y-intercept is negative 3. My slope is down 1 over 1. Okay, when I draw my line, I have to be careful. This is a strict inequality, so anything that's strictly greater than or strictly less than, that's going to be a dotted line. So I'm going to draw my dotted line, and in both directions. It helps to use a ruler here, so it's exact. I don't have that luxury right now. Okay. Second equation. Okay. If I were to solve for y, I could add 6x to both sides, and I would get y is less than 6x plus 1. Okay. Before I continue on with this, I want to talk about this first line again. Y is greater than negative x minus 3. I also need to shade. Okay. I need to shade the direction that include the correct points. Okay. I'm going to test the point 0, 0. Okay, 0, comma 0. I'm going to test that point. That is, I'm going to put 0 in for x and y and see if that is true or false. Is 0 greater than negative 3? My answer is yes. So I'm going to shade the direction that contains the point 0, 0. I'm going to shade all of this region. Okay, this region, this half of the graph, contains the point 0, 0. So that is my correct region for that particular inequality. Okay. Now for my next line, I solved. I got y by itself. Let's graph it. Okay. Y-intercept of positive 1. My slope is up 6 over 1. And this is again a strict inequality, so I've got a dotted line. Okay. 0, 0 is to the right of that line. So if I plug in 0, 0, I want to see if this is true or false. Is 0 less than, that cancels, 1? Is 0 less than 1? Yes. Okay, so I'm going to again shade the region that has 0, 0, and that's this stuff on the right side of this black line. Okay, now where those two regions overlap, that is my solution set. I'm going to use a highlighter. Okay, right here. Okay, this region contains all points in both inequalities that make each inequality true. So that is my solution set. Next example. Okay, I had 4x plus 2y is greater than or equal to 8. If I subtract 4x from both sides, I get, I'll bring that down here, okay, 2y is greater than or equal to negative 4x plus 8 divided by 2. So y is greater than or equal to negative 2x plus 4. Okay, let's graph down 2 over 1. This is a greater than or equal to, so it's going to be a solid line. Okay, again, I'm going to test 0, 0. Okay, well, 0 times any number is 0. Is 0 greater than 4? No. So I'm not going to shade the area that contains 0, 0. I'm going to shade the other side. Okay, and just a light amount of shading just so we can see that part. Okay, so that's the correct solution set. Now I'm going to do my other line. Okay, if I distribute, I get y is less than negative 2x minus 10 plus 7, or y is less than negative 2x minus 3. Let's graph that. Negative 3 is my y-intercept. I go down 2 over 1 for the slope. And that is a strict inequality. So this needs to be a dotted line. Again, I'm going to test 0, 0. And 0, 0 is up to the right from our line. So is 0 less than negative 3? No, it is not. So I'm going to shade this direction, okay, to the left of that line, since 0, 0 is not in this region. Okay, so these are all my true points. And notice that these two pieces do not intersect, so this has no solution.